Okay, ladies and gentlemen, so on Tuesday or on Monday, we watched a video, and Tuesday we practiced writing exponential growth and decay models. So today we are going to use them. So here we go. So if we deposit $200 into a bank account and every year it increases by 12%. So here's our initial value. Since it increases, we would do 1 plus that 12%, which looks like 1.12. So then how much money is in the account after 3 years? So your variable is always your time in whatever is it's being measured in. In this case, it's years. So we are just going to do 200 times 1.12, and then we're going to raise it to the, instead of raising it to the x power, we're going to take out the x, we're going to put in a 3. So we're just evaluating this function. So if I go to Desmos, and then I can do 200. 1.12, raise it to the third power, and I get 280.98. So since we're dealing with money, we want to round it to 2 decimal places. So since this third number is a 5, that 8 becomes a 9. So I'm going to go back here, and that would equal then 280.99. And that's dollars. Alrighty, so if we look at our next example, the population of an apartment building is 4,000 people. Every month the population goes down. So we have our initial value, and then we did 1 minus that 0.12 to get that 0.88. So how many people are in the apartment building after 5 months? So again, we're going to take this, and instead of the x, we're going to substitute in a 5 for it. So when I go into my calculator, I can get rid of those. So I've got 4,000 times 0.88 and raise it to the 5th power. And it's 2,110. Let's see. So after 5 months, 2,110.93 or so. I'm not sure how we're going to round that one, but okay, 2. Technically, since it's people, we probably should like round this a little bit. Now, technically, it's going to be less than 2,110. So like this would round up to 2,111, but it's really less than that. So I would just say it's 2,110 people. So we can round to the nearest person. But because we don't want to round this up because of dealing with the fact that it's not quite, it's less than 2,111, but we can't have that 0.93 of a person. Alrighty. Next example. So here we're starting with $500, and the interest is 8% every year. So 8%, I'm going to change that to a decimal. So that's going to be 0.08. Interest is being added to your account. So it's going to be we're going to do 1 plus that and get 1.08. Alrighty, so we're going to start off with 500. My growth factor is 1.08. I'm going to raise it to the x. So again, this is a skill that we did on Tuesday, or the Monday's video, and then the Tuesday was practice. So now I'm going to take my equation, and I'm going to substitute in a 6 for x. So if I do 500 times 1.08 and raise it to the 6 swoops, raise it to the 6th power, that gives us 793.437. Again, dealing with money, we want to round to 2 decimal places, so that would round to 0.44. and that's money. So that's how much money would be in the account after 6 years. And example number 4, and this looks like it's our last example. Okay, so certain stock was worth $42. Every hour it goes down by 15%. So our equation, so it's going to be our initial value times our growth rate, or growth factor rather. And so since it's going down by 15%, I want to do 1 minus that 0.15, which gives me 0.85, and I'm going to raise that to the x. So after 4 hours, we do 42 times 0.85, raise it to the fourth power. Gives us 21.924. So again, since we're dealing with money, we want to round to 2 decimal places. So 21.92 would be our answer. And that's how much it would be worth after $4. I don't think I suggest buying this stock because that's really not good. So there you have it. So when we're just using our exponential equations, we're just substituting in the value that we're looking for and for x. So like at 4 hours, we just substituted in for x. So again, if you have any questions, please message me before you turn things in if something's not quite right.